Okay, so in the last lecture we found these following expressions. So if you have this particular point as point P, then point P can be represented by 2 points x and y in Cartesian system, or it can be represented in polar system by specifying the value of r and value of theta. Now there are two basis states. In Cartesian the basis states were I cap and j cap, and in the polar the basis states were r cap and theta cap. We saw in our last couple of lectures r cap was found to be cos theta I cap plus sin theta j cap. Now the question is, can we find a similar representation for theta cap? So how does theta cap look in if written in I and j? This is our main idea now. Okay, look closely. This is the direction of r cap. Look at the diagram. This is the direction of r cap. Then the direction of theta cap is perpendicular to direction of r cap. So this is the direction of theta cap. Now the question is, how do you know that direction of r cap? If it is in this direction, then the direction of theta cap is perpendicular to r cap. Because the very idea of coordinate system that we are using, whether it be Cartesian, whether it be polar, we concentrate on the fact that the basis states are orthogonal to each other. That is, if I look at the direction of I cap and if I look at the direction of j cap, then the idea is the dot product must be 0. It means they are orthogonal to each other. Similarly, we are looking at orthogonal polar coordinate system where the basis states r cap and theta cap are orthogonal to each other. So r cap dot theta cap must give us 0. Okay, so using this idea that r cap and theta cap must give us 0, guess the value of theta cap. Let us try to guess. First of all, theta cap is perpendicular to r cap. This is quite clear. Okay, so let's try to find the x component of theta cap. So let me remove this. Okay, so let us try to find out the x component of theta cap. Draw a line here. Okay, if this is theta, then this is theta. Now if this is theta and we know that this is 90 degree, then what is this angle? This angle is 90 degree minus theta. And what is theta cap? Theta cap is a unit vector whose direction is perpendicular to r cap. This is my theta cap. So if you look closely, the x component of theta cap is actually in the minus x direction. So one thing is clear, that the x component will have a minus sign, and I cap. I cap represents the x axis or x component, and minus sign represents that theta cap has the x component along the negative direction. Now what is x component? X component is cos, instead of theta what we will use, 90 minus theta. And what is cos 90 minus theta? It is sin theta. So what is the first term? The first term is minus sin theta I cap, plus similarly look at the second term. Second term will be along this. So it is clear that the second term of theta cap will be along the positive y-axis. So the second term is going to be sin 90 minus theta. which is cos theta, and since it is in positive y direction, so no minus sign, only j cap. You can easily check that these expressions satisfy the condition that they are orthogonal, that is r cap dot theta cap is equals to 0. There is one more interesting thing. dr cap divided by d theta. Do this derivative and you will get theta cap. Quite interesting, right? So when we were evaluating in our previous lecture dr vector divided by dt, we had two expressions. One expression is the derivative acting on the magnitude of r, which is dr by dt into r cap. We don't want to look at the first term. In this part, we want to look at the second term, where the derivative was actually acting on the r cap. Okay, so let's find it very simply. So d r cap divided by dt is equals to, now r cap is a function of theta, so it is better I write d r cap divided by d theta into d theta divided by dt, because actually here theta is a function of time. So dr cap by d theta is theta cap. So let me write this first term as theta cap and the second term is theta dot. See, we found the same expression for the second term as before. So it becomes what? This is my velocity in polar coordinate is equals to r dot r cap, which was the first term, which is easy, and the second term is r, and what did we get? We get theta dot theta cap. Interesting, right? So we derived it in two different ways. So I hope now everything is clear, that when velocity is written in polar coordinate, it means you have to write it in terms of basis states r cap and theta cap. And when you are asked to write velocity in Cartesian coordinate, then you have to write the velocity in terms of basis state I cap and j cap, which is very easy. Here we had x dot and here we had y dot. Understood? So we will discuss more